Happy New Year, everybody. Today is January 1st, 2019. Baz and I were working on a diagram here. He made it a lot prettier than this. Baz, good job. But that diagram I'll post to the bottom. It's basically a count of independent objects in the Milky Way galaxy. Now, I'll link it to the bottom, so go ahead and click on it so you can see what I'm talking about. I don't want to show this one because this is ugly. Um, the total stars on here, it isn't the number of stars themselves. It's a count of individual objects. So it includes asteroids. It includes the moon. It includes nebula, things like that. Individual objects that people consider as a complete object. Based off of the apparent magnitude. So, and I don't know if you guys realize this, but apparent magnitude isn't absolute magnitude. They're two different things. Apparent magnitude is how bright something appears from your vantage point. It's apparent magnitude. And absolute is its magnitude from a distance of 10 parsecs. And I think a parsec, I can't remember how long a parsec is. I have to look that up. But basically, a parsec is very close to a light year, and it's very far away. And for instance, the sun's apparent magnitude in the sky is like negative 26 or something like that, and its absolute magnitude from 10 parsecs I think is like negative 4. So big difference when you stick it out really far away. Anyways, in this graph right here, there's a lot to work on. Basically, what I wanted to get across is the dimness of an object has a relationship with how many of these objects are in the galaxy. Meaning, what we can see is very limited because of objects, and being that they're dim, the dimmer, the more they're going to be. So, large O-type stars, are really bright, but they'll be really dim, and no matter how bright they are, it's going to be harder to see them when they're further out, which means there's going to be a lot more of them, and that number just goes up by a ratio. I think it was y equals 1 over x, I believe. But enough of that. Good job, Bess. Now, the other portion of this talk is something that I really wanted to get across to people. And there's two aspects to this. The location of Mars on the Walensky-Taylor diagram here. I have Mars sitting below Venus. I'll link this paper to the bottom. I think I did a talk on this before, but it's down there a little bit further beyond to the, what was that? That would be the right of Venus and a little bit below. Of course, this is subject to change. I would seriously consider Mars to be around 32 billion years old. Now, it stinks that in the culture of the scientific establishment that their minds are locked into place. They cannot have anything in the entire universe be older than 13.7 billion years old. It locks their brain into trying to force objects and everything they observe to fit like a steel trap. If it fits inside this little trap here, then it's A-okay, and as a scientist we won't be looked down upon or considered as a crank or a crackpot or anything like that, and my career is safe. Being that I don't have a career in astronomy, and I'm not planning to have anything to do with astronomers because I'm not cut from the same cloth as them, I can basically speak my mind. And my mind has it to where Mars is so freaking old that it just would blow your mind as to how old it actually is. It's at least 3 times older than the Earth. At least 3 times older. It no longer has a magnetic field. The surface is completely distraught. I mean, there's no volcanic activity at all. See what else makes it old. The atmosphere is almost completely depleted. of nitrogen, and that's one aspect of the theory that I was working on, is that nitrogen's gone. Mostly gone. I mean, it's mostly carbon dioxide in the atmosphere, and even the atmosphere itself as a whole is gone. It's basically a vacuum. A human being cannot walk around on the surface of Mars without having a spacesuit on. Does that sound to you like it's an object that's the same age as the Earth? I don't think so. Mars is really, 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 really old, and it's a dead world. Apart from the moon, Mars is going to be another object in the future that if we ever visit, it's going to be an object that we visit that's much older than the Earth, just like the moon is. I also believe the moon is, who knows, tens of billions of years old. But I can't remember if I put a specific age on that. And I drew up a little diagram here, and if you go to Wikipedia and you look this stuff up, or just any, website on Mars and how old the craters are on Mars and how old the surface features are, you'll get a max age for those surface features of around 4.5 billion years. Is when they claim the entire solar system formed at the same time, which is completely ridiculous in my eyes. So you have 32 billion years, Mars being that old. Now this is all hypothetical, this is up to change, but I know it's really, really, really old. And the impact crater formation would be around 27.5, that's when it would start. So the surface features that we see on Mars would just stick right about here. And if you notice, there's 24 billion, and you have 16 billion. In another paper, I'll link this to the bottom as well, I have Mars is around 14.67 billion to form its actual core, which means that's about how long it took to form. And it does not include the mantle and all that, so it could be older. This is just an estimate, and it needed to be said, because that by itself, Mars took longer to form than what the experts say the age of the entire universe is. So right there you have a contradiction. And then you have to have Mars actually dying, losing all its heat, losing its ability to produce a magnetic field, losing the majority of its atmosphere, and then very, very far into the future, when Mars is already dead, there's no life, there's no oceans as we know them on Earth, and then it's just wandering the galaxy from solar system to solar system, taking up orbit around other stars, and we just happen to observe it in its current orbit and saying, well, that object formed exactly where it is. That's not a good rationale. You have to look at that object and use your brain, look at it. And if anybody wants to go look at pictures of Mars' surface, that thing is really, really old looking. I mean, just look at the pictures of it. It's just like, wow, that thing's old. It's like looking at the Grand Canyon, only it's as if the Grand Canyon had been completely disintegrated and it's just leaving a bunch of pebbles and flat rock all over the place because it's been pulverized by ablation and surface impacts. And it takes time to do that. So then they say, well, Mars, this is the entire history of Mars, the geological history. I'm like, no, Mars is vastly older than the amount of time it took for it to form its impact craters. And the reason why I want to talk about this as well is that look at a lot of science articles and look how a lot of the scientists, they don't ever talk about things that could be older than the universe. They don't want to stick out like a sore thumb. They don't want to be considered crazy or crank or crackpot. And it's reasonable because they want their careers to prosper. They want to be in the in group so they can get to use the big telescopes and work in large organizations and get a good feeling of importance from it. But from my standpoint, I don't get my feeling of importance from that. My importance is to really get to the bottom of it and really consider why things are the way they are and actually somehow explain how they got to be that way without any type of peer pressure to conform, without any groupthink, without anybody telling me, say, oh, you're just crazy for thinking Mars is, 32 billion years old, which I think is completely reasonable. But anyways, we have a spacecraft on there is digging into into the crust a little bit just to get some soil samples, I guess. And it should be interesting to see what they come up with. But anyways, to recap, I'll post this to the bottom. Baz, good job on that. And I just wanted to talk about Mars a little bit. I mean, when we go there, we shouldn't really be surprised that it's just this dead rock that is very uninteresting. But alright, you guys, later.